Welcome back, Science 10. This video marks the beginning of the reaction rates section. The first experiment you'll be doing is investigating how the rate of a reaction is affected by temperature. So that's basically what the purpose is, to determine the effect of temperature on reaction rates. So maybe the first thing we should do is look at what is a reaction rate. So I included that with the background area here. Since this is the first lab, we'll do the background together. So what is meant by rate of a reaction? Basically, how fast a reaction occurs. If you imagine you driving your car, how fast you're going is a rate of change of distance over time. Well, with reaction rates, we don't have distances, we have something else, maybe something being used up or something being formed. So that is how you measure a rate in chemistry, by looking at the disappearance of something or the appearance of something. So if you increase the temperature, what does that do? So if you take a look here, the hypothesis, I believe that the rate of a reaction will increase, so the rate gets faster when, what do you think? When you increase temperature, decrease temperature, or when you leave temperature the same. So pick one of those three items to place right here. And you can kind of predict which one you think what it likely is due to common experience. So to make the rate go faster, do you increase temperature of the water, decrease temperature of water, or just simply leave the temperature the same? Okay? So this lab is based on the textbook, page 256 to 257, which uses Alka-Seltzer tablets, dropping Alka-Seltzer tablets in water, watching them dissolve, and then when they're done dissolving, that's the end. So we're looking at the rate of Alka-Seltzer tablets disappearing. Now I changed up the lab a little bit, so that's outlined by the bottom here. For the most part, the materials you'll be using are the same ones on page 256. The procedure is somewhat similar, safety precautions similar. You need to wear goggles. We're going to use 4 different temperatures of water in a 250 ml beaker. Put about 200 mils of water in there, so it's a 250 ml beaker, but you don't want it right up to the top. You want it to be about 200 mils. And basically 4 different temperatures, so kind of cold, room temperature, warm, hot. So I'll have some, in terms of cold, you can even just use tap water. It's fairly cold as well. You don't want them too cold. I might get some ice there too, so if you need some ice, maybe you can use that, but cold tap water would be cold enough. And then I'll have some boiling water, so you'll be able to kind of make these different temperatures by putting a little bit of hot water with a little bit of cold water, then you'll make warm, etc. Now, still using 1 tablet for each of these, what I'm going to get you to do is get 1 Alka-Seltzer tablet and cut it into fourths. So as best you can, try to cut that into fourths, 4 equal pieces. So use a little knife here and cut it into 4 pieces. And basically what you're doing is you're timing how long it takes for the Alka-Seltzer tablet to completely be used up. So that's how we're going to time the rate. The rate is going to be determined, basically we're not actually figuring out the rate, we're just kind of looking at time. Which one's faster, which one's slower, etc. To be an actual reaction rate, we'd have to figure out how many grams of tablet we have and divide that by time, and then that would give us how many grams per second are being used up. But we're just going to look for time in this case. The chart that you have, similar to this. So once again, cold temperature, room temperature, warm temperature, boiling temperature. You can use a thermometer, tell me what the temperature is, what is room temperature, what is the warm temperature of your water, what is the boiling temperature of your water, and then from there, how long does it take for the tablet to disappear? Okay? So just in terms of description of what type of temperature is right there, but I actually want you to measure the temperature with a thermometer. No graph, of course. I think the textbook has or wants you to do a graph, but we're not going to worry about that. And usually here, the usual things in the conclusion, what were you going to do? You can say the purpose was to, and then answer that. What do you think would happen? Here's where you talk about your hypothesis. It was thought that, da-da-da-da-da, and then what did happen? Did your results support your original prediction? What happened was, da-da-da-da-da, it was or was not similar to my prediction. Okay, so once again, the conclusion serves as kind of a big summary. a person can take a look at the conclusion and tell exactly what happened in the lab. And then there's a few follow-up questions at the end there. So describe the effect of increasing temperature has on the rate. The kinetic molecular theory suggests that particles are constantly moving, and they move quicker at higher temperatures. So if we think of that, if things move faster at higher temperature, so the atoms that make up an Alka-Seltzer tablet and water itself, how does that explain what happened in your lab? So use this theory to explain what you witnessed in there. And then number 3, kind of looking at real life things, list and explain an example of a reaction which temperature is altered to increase the rate of a reaction. So think of something in everyday life. If you want to make something speed up, a certain reaction, what type of situation is that in which you want the reaction to increase? And then what in real life would you want a reaction to slow down? A lot of these you can get from the kitchen, examples of kitchen stuff, things that happen in the kitchen. That's a huge hint. But if you run into issues, or if you simply can't think of anything, just track way down and I'll give you a better hint as to what you can use for that number 3. Okay, good luck with the lab.